What if I told you that the route you took this morning, your social media feed, and even the way banks catch fraud are all powered by the answer to a simple puzzle from the 1700s? It sounds kind of crazy, right? Well, let's dive in, because this story of a seemingly impossible riddle is actually the foundation of our modern, connected world.
So our story doesn't start in some high-tech lab. Nope, it starts in an 18th century Prussian city with a really weird problem.
Okay, so this is the city of Königsberg. As you can see, it's built around a river, and it's got these two big islands smack in the middle. To get around, the city and the islands were all connected by a total of 7 bridges. A pretty simple layout, you'd think, but it sparked a citywide obsession.
And here's the question that had everybody talking. Could you go for a walk, cross every single one of those 7 bridges, but, and here's the catch, without ever crossing the same bridge twice? It sounds easy enough, doesn't it? Well, people tried for years, and for years, nobody could do it, or prove that it was impossible.
That is, until a brilliant mathematician, Leonhard Euler, heard about the puzzle. And what's amazing is that he solved it without ever even visiting Königsberg. He knew the answer wasn't in your feet, it was in your head. It was about thinking about the problem in a completely different way.
Euler's huge breakthrough was this. He realized that the exact path you take on a land doesn't matter at all. The only thing that's important is the connection, the sequence of bridges you use to get from one chunk of land to another. And that shift in perspective, it was an absolute game changer. In fact, that single idea gave us a powerful new language to describe the world, and it basically created an entirely new field of mathematics. He invented what we now call a graph. Now, a graph is just a super simple way of showing relationships. The objects, in our case the pieces of land, are called nodes, and the relationships, or the connections between them, the bridges, are called edges. That's really it. It's this beautiful, simple way to make sense of complex systems. In this image right here, this is the aha moment. On the left, you've got the real-world map of the city. But on the right, you see Euler's graph. He just stripped away all the stuff that didn't matter, the buildings, the roads, and he was left with just the pure problem. 4 nodes for the 4 land masses, and 7 edges for the 7 bridges.
Once he saw it like this, the answer became crystal clear. Euler figured out that to pass through a piece of land, to arrive by one bridge and leave by another, you need an even number of connections. But in Königsberg, all 4 landmasses had an odd number of bridges. So the walk wasn't just hard, it was mathematically impossible.
Now, this basic idea of nodes and edges can get a little more interesting. Think about Facebook. If you're friends with someone, they're friends with you back, right? It's a two-way street. We call that an undirected edge. But then you have Twitter. You can follow someone, and they don't have to follow you back. That's a one-way connection, or a directed edge.
And of course, for a computer to make sense of all this, you can't just hand it a drawing. You have to translate this visual map into a language that it can actually read. We do this by creating simple lists or tables that just spell out exactly which points are connected to which.
Okay, so it's a cool story, right? A 300-year-old puzzle gets solved with a clever diagram. But how does this abstract idea actually become the technology that we use every single day?
So yeah, why does any of this matter? What does Euler's idea of nodes and edges really do for you? Well, it turns out pretty much everything.
Let's start with Google Maps. Every time you ask for the fastest route, you're basically asking a graph theory question. It's the 7 bridges of Königsberg, but on a massive global scale. So here's how it works. First, the entire world is turned into a giant graph. Every intersection is a node, and every road is an edge. Second, each of those roads gets a weight, a number that could be its distance, or the speed limit, or even real-time traffic. And finally, a really smart algorithm searches through that entire, massive graph to find the path with the lowest total weight, which gives you the fastest route.
But graphs are not just for maps. They can model any situation where you have to do things in a certain order. Think about getting dressed. Each piece of clothing is a node, and an edge from socks to shoes means you have to put on your socks before your shoes. This simple concept is used all over the place to manage incredibly complex projects. And once you start looking, you see graphs absolutely everywhere. Your social network is a giant graph. The entire internet is a graph, with websites as nodes and links as edges. Banks use them to spot fraud by looking for weird patterns of transactions between accounts. It's truly the invisible architecture of our digital lives.
So what's the really big idea here? What's the main takeaway? Well, it's about so much more than just a clever way to organize data.
It's really a fundamental shift in how we see things. Graph theory gives us a new lens to look at the world, not as a bunch of separate, isolated objects, but as a deeply connected web of relationships.
And that right there is their true power. By turning a system into a graph, we can suddenly analyze it, find bottlenecks, see hidden communities, and uncover patterns that would have been completely invisible otherwise. It's a tool for making sense of complexity.
So, the next time you use GPS or scroll through your social media, just remember the 7 bridges of Königsberg. Euler's solution gave us more than an answer to a puzzle, it gave us a new way to see. Now that you know the language of nodes and edges, what hidden networks are you going to start to notice?